This video, we're going to prove the following fact. If n is equal to p1 to the k1, p2 to the k2, all the way down to times p to the p sub r to the k sub r is a prime factorization of n greater than 1, then this here is satisfied, this inequality. So let's consider what the proof is going to be like. Before we get into the mathematical proof, let's talk about proofs for a moment. If you're into watching proofs, I advise you to subscribe to my channel, as all we do here are mathematical proofs. Okay, so let us get this inequality out of the way. N divided by sigma of n. Well, this is p1 to the k1 times p2 to the k2. This is what n is. P sub r to the k sub r. And in the bottom, we're going to have 1 plus p1 all the way up to p1 to the k1 times 1 plus p2 times p2 squared, etc., all the way up to p sub 2 to the k sub 2, all the way down to 1 plus p sub r plus p sub r squared plus p sub r cubed, all the way down to p sub r k to the r. Now, every p being a prime is positive and 1 is positive. This is the sum of positive numbers. This is all sum of positive numbers. This is the sum of positive numbers. This bottom is greater than, or maybe equal to, well, it's greater than p1 to the k1 all the way down to pr to the kr. Why is that? Eventually, when you file this out, you'll be multiplying those r terms, and you will get this. But there's many other terms you're going to multiply. You're going to multiply p1 by p2, maybe by 1. You multiply 1 times p2k to the 2 times pr to the k sub 3. And those are all going to be positive. Okay, so let's formally state that. This here is going to be less than, we're going to keep the numerator. We're going to keep the numerator the same. But I'm going to make the denominator smaller. I'm going to make the denominator smaller by only multiplying these. PR to the KR. But that's 1. Okay, so I showed that this, which equals this, which is less than that, equals 1. That means this is less than 1. So I have that one. Now, the hard part. I need to show that this here is less than that. Okay, so remains to show that 1 minus 1 over p sub 1 dot 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 times 1 minus 1 over p sub r. This is less than n over sigma of n. But n, of course, is p1 to the k1, p2 to the k2, all the way down to pr to the kr. And if I can, let me just move this over a little bit. I don't think I really can, but I'll do it the hard way. I wrote down n, and now I'm going to write down sigma of n. That's n right here, and here's sigma of n. It's 1 plus p1 plus p2 all the way up to p1 to the k1 dot 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 1 plus pr to the kr. Oh, excuse me. 1 plus PR to the first, all the way down to plus PR to the KR. Okay, so what I need to show is that this is less than that. That's what I have to show. So let's put a question mark here. Now everything is positive. So I can move factors around and the inequality won't change. Now I'm going to rewrite this. That's the same as P1 minus 1 over P1 times P2 minus 1 over P2 all the way down to PR minus 1 over PR. And I want to show that it's less than the right hand side. P1, K1 all the way down to PR to the KR over this. 1 plus P1 all the way down to P1 to the K1 dot 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 1 plus P sub R all the way down to plus P sub R to the K sub R. Now I'm going to move this bottom to the other side, and I'm going to move this bottom to the other side. So what I have now is P1 minus 1 times P2 minus 1 all the way down to PR minus 1 times what I just moved. 1, which is this here. 1 plus P1 all the way up to P1 to the K1 times dot 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 1 plus P sub R all the way up to P sub R to raised to the K sub R. And this is supposed to be less than, well, when I multiply this bottom by this top, all the powers increase by 1. We get P1 to the K1 plus 1 all the way down to P sub R raised to the K sub R plus 1. Okay. Now, I want to read, again, I have a question mark here. I haven't proven it yet. Now, I want to combine this one with that one. I'm going to pair them up. The PRs with their P sub R's, etc. So what I have is P1 minus 1 times 1 plus P1 all the way up to P sub 1 to the K sub 1 all the way down to PR minus 1 times 1 plus P sub R all the way up to plus P sub R to the K sub R. And is it less than the right hand side, which is P1 to the K1 plus 1 all the way down to P sub R raised to the K sub R plus 1. Now, when you multiply this by this, let's formally do it. Let's do P sub I minus 1, so the general one, times 1 plus P sub I plus P sub I squared all the way down to P sub I raised to the K sub I. Okay, so when you multiply each of these by P sub I, the powers are going to go up 1. So the 1 becomes Pi plus This one becomes pi squared. This one becomes pi cubed. Eventually, the one before, when you multiply it by p sub I, it'll become, the power will become k sub I. And when you multiply the pi by the last one, you're going to get p sub I to the k sub I plus 1. But then you have to minus all of this. You have to minus 1. So we're going to have minus 1 and plus this. But look, we have to take away p1. We have to take away p2. We have to take away p3. We have to take away p sub I. So what we're left with is this and the 1 that we just took away. Okay, so what we have is, now, well, maybe I didn't do that so hard. We definitely have the 1. We're going to have, no, we're actually going to have pi to the k sub I plus 1 minus 1. And this is for all I. So for the first one, we're going to get p1 to the k1 plus 1. Let's write that a little bit neater. So we're going to get p1 to the k1 plus 1 minus 1. And we're going to get this all the way down the line. We're going to have the next one, which is in here. We're going to have p2 to the k sub 2 plus 1 minus 1. All the way down to p sub r to the k sub r plus 1 minus 1. And this is supposed to be less than this. But this is pretty clear. This is less than p1 raised to the k1 plus 1. It's 1 less. So this is less than this. This one is a little bit less than p sub 2 raised to the k sub 2 plus 1. It's less than the second one. The third, fourth, fifth, they're all less. This last one is less. So we can write this up. Since in general, p sub I to the k sub I plus 1 minus 1 is less than p sub I to the k sub I plus 1, this implies that this inequality is valid. P1, so I'm just going to recopy this. Just going to recopy this. P1 to the k1 plus 1 minus 1 times p2 to the k2 plus 1 minus 1 dot 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 to pr to the k sub r plus 1. This is less than p1 to the k1 plus 1 times p2 to the k2 plus 1 minus 1, all the way down to pr to the kr plus 1. But now, everything I did, maybe I should have written it, everything I did was if and only if. This line, if and only if the next one. If and only if the next one. If and only if the next one. If and only if this one. But this one is true. So we come way up here and we're like, yeah, this is true. So what did I show just now? Remember earlier I verified the less than 1. Now I verified that this mess is less than n over sigma of n. We verified that. Combining both inequalities, we have the following. We have that this top statement is valid. We have that this is valid. It'd be really great if I can copy it. Okay, copy. Okay, and this is pretty much what we wanted to show, and I did. This last line is valid. Okay, and that would complete this proof. A lot of alphabet soup in this proof, but it's doable. If I can do it, you certainly can. See you guys in the next video. Don't forget to subscribe to my channel. Click the like button. See you guys in the next video. Watch and learn.